Hello students, welcome to the new video. This is the third video in first year JNTH engineering basic electrical engineering subject first mid previous year bit paper questions and solutions. In the first video of this series we have discussed the previous year bit paper questions about the basic circuit components, energy sources, Kirchhoff's laws and Ohm's law. In the second video, we discussed the previous year bit paper questions of series and parallel connection of resistors, inductors and capacitors. In this third video, we will discuss the previous year questions and solutions of mid paper about the network theorem concepts. So let us start with the first question. So first question is about the superposition theorem. We all know superposition theorem can be applied only to the linear and bilateral networks. You see the question is superposition theorem can be applied only to which networks? It is applied only to linear and bilateral networks. So answer is C. Second question, the theorem which can't be applied to the multiple source network is dash. Thevenin's theorem can be applied to the network which is having multiple sources, and Norton's theorem also can be applied to the network which is having more than one source, and superposition theorem also can be applied to the networks which is having multiple sources. But only reciprocity theorem cannot be applied to the network which is having the multiple sources. Only reciprocity theorem only cannot be applied to the networks which is having more than one source. So it is applicable to the network which is having only one source. So answer is D. Next third question. This third question is about the Thevenin's theorem and Norton's theorem. While determining the RTH Thevenin's resistance in both the Thevenin's and Norton's equivalent circuit, what is the procedure? Only current sources made dead, or only voltage sources made dead, are all independent sources made dead, or all current and voltage sources are made dead? So which one is the correct answer? You see, all independent sources are made dead. So while determining the RTH value, all the independent sources are made dead. Dependent sources are not disturbed. So you might be confused with option C or option D, but option D is saying all voltage sources and current sources are made dead. It is not correct. All means dependent sources also will come in the option D. That is not correct. Only independent sources are made dead. Like ideal voltage sources are replaced with their internal resistance, that is zero resistance short circuit. That means ideal voltage sources are short circuited, ideal current sources are open circuited, and practical voltage sources, practical current sources are replaced with their internal resistances. So this is the procedure while calculating the Thevenin's resistance. Next fourth question, it is about the maximum power transfer theorem. So in a circuit, whenever load resistance is equal to the source resistance, from the source to the load, maximum power will be transferred. So during this maximum power transfer condition, what is the efficiency? So during maximum power transfer condition, let us say this is a source and it is plus Vs, and let us say this is the source internal resistance Rs and this is a load resistance RL. Let us say this load resistance is a variable. So whenever we vary the load resistance value is equal to the internal resistance, then maximum power will be transferred from source to the load. That means now RS value and RL value both are equal. Let us say 100 watts of power is delivered by the source, 50 watts of power is wasted in the internal resistance, remaining 50 watts is delivered to the load. Then what is the efficiency? Efficiency equal to output power by input power. Output power is power delivered to the load, that is 50, and input power is power delivered by the source, that is 100. So into 100. So what is the efficiency? Efficiency is how much? 50%. During maximum power transfer condition from source to the load, the efficiency is only 50%, because out of the 100 watts, half of the power is wasted in the internal resistance, remaining half only will be delivered to the load. Because of that, only efficiency is 50%. So answer is B. Next fifth question, again it is about the maximum power transfer theorem. The maximum power transfer theorem can be applied to which circuits? either only DC circuits or only AC circuits, or both DC and AC circuits, or neither of the two. So you see, maximum power transfer theorem can be applied to both the DC circuits as well as AC circuits. So answer is C. Next, sixth question. It is about again, which of the following theorem is applicable for both linear and non-linear circuits? Superposition theorem is applicable to only linear circuits. Thevenin's theorem is also applicable to linear circuit. Norton's theorem also applicable to linear circuit. So, but he is asking which theorem can be applied to both linear as well as non-linear. So, none of these. So, answer is what? The superposition theorem, Thevenin's theorem, Norton's theorem, all these theorems are applicable to only linear circuits. Next, let us see the fill in the blanks questions. So, what are the questions we are discussing? All these questions were asked in previous year mid-paper questions prepared by the JNTH. Now, let us see the fill in the blanks. First questions. When the superposition theorem is applied to any circuit, the dependent voltage sources in that circuit is always. So, whenever we are applying the superposition theorem, usually we keep one source active and remaining all other sources we replace with their internal resistance. We consider only one source active in the superposition theorem and remaining all other sources are made dead. But while only independent sources are made dead, but dependent sources are not disturbed. That means while we are using the superposition theorem, dependent voltage sources are always present in the circuit. That means they are active. So dependent sources are always active while we are working with the network. Superposition theorem requires as many circuits to be resolved as there are. How many sources? So how many sources are there? So how many sources are there? Those many number of equations will come. Let us say if 3 sources are there in the circuit, we will take 3 cases, 3 different circuits will come. So how many number of sources are there? Those many number of circuits will come. Next question. The power can't be measured by dash theorem. See, with help of superposition theorem, we cannot determine the power. So with help of superposition theorem, we cannot determine the power. With help of superposition theorem, we can find out only voltage or current responses, but we cannot find the power. Superposition is not valid for dash responses. Superposition theorem is not valid for power responses. It is valid only to calculate voltage or current responses. Next question. In Thevenin's equivalent circuit, resistance is in dash with the Thevenin's voltage source. So if you see the Thevenin's equivalent circuit, we will be having one voltage source whose voltage is Thevenin's voltage and one resistance, that is Thevenin's resistance, and it is in series with the load resistance. So in Thevenin's equivalent circuit, resistance, this RTH, is in dash with the voltage, it is in series. So answer is series. In Thevenin's equivalent circuit, resistance means Thevenin's resistance is in series with the Thevenin's voltage source. Next question. While determining the RTH means Thevenin's resistance, in Thevenin's and Norton's equivalent, all independent sources are made dead. So all independent sources are made inactive. So all independent sources are made inactive. But dependent sources are not disturbed. Next question. Maximum power transfer theorem can be applied to both AC circuits as well as DC circuits. So this is about network theorems, previous year questions and solutions of first mid bit paper. Thank you so much. This is the third video lecture in this series, and in the next lecture, lecture number 4, we will discuss about the transient analysis in the unit number 1. That is the last video of our unit number 1. Thank you.